Okay, so by mistake, I accidentally clicked stop recording instead of pause recording. So this is now going to be in 2 videos, but I guess we'll just kind of survive. So we talked about projection, we talked about force. Now let's talk about what work is. So work is the force causing the movement of an object. So we got 2 different formulas for this. Work can equal the remember how we just found those vectors when we did the projection? So if we take the magnitude of that projection of the force onto whatever vector we're talking about, if we multiply that by the magnitude of that vector that we're projecting onto, that will give me work. So those right there, those are magnitudes. Another thing that we can do is if we have a force vector, dot product it with the vector that we are moving along. So that is a dot product right there. So work is done by a constant force F that moves along PQ. So in case you're like, why is there a force moving along some vector? When would this happen? So think of it as, in this next problem, we're going to be talking about a door. So, here's an example. To close a barn door, a barn's sliding door, a person pulls on the rope with a constant force of 50 pounds. At a constant angle of 60 degrees. Find the work done in moving 12 feet to its closed position. Alright, so let's draw a picture. Barns are, well, traditionally, I don't think I've ever really seen a red barn. At least not as red as I've seen it in other places. So there is my barn door. See, look at him saying door. Now, this barn door is going to slide along this guy up at the top, going in this direction, right? He's going to be go ahead and slide over, and we want to move him 12 feet. And then there's this rope that's going to be kind of pulling down a little bit because, you know, you're not tall enough to stand at the top of the door. So this is 60 degrees right here, and you are pulling with a force of 50 pounds. All right, so first let's talk about the rope vector. So the rope vector, its magnitude is 50, so I'm going to have 50 times the cosine of its direction, which is 60 degrees, and 50 times the sine of its direction. So we know that the cosine at 60 is a half, so half of 50 is going to give me 25. We know that the sine at 60 is square root 3 over 2. So 50 times square root 3 over 2 is going to give me 25 square root 3. All right, so there's the rope vector. Now let's talk about the door. So we'll call him D. So the door is just going to go 12 feet, and it's going to be going in the right direction. So that means it's going to go entirely horizontal and entirely positive. So, because remember, right is positive. So that means that I'm going to have a 12 right here and a 0 for that vertical part. If you wanted to think about it as an angle, my cosine over in that direction is, or I'm sorry, my angle measure over there is 0 degrees. So if you had the cosine of 0, that's 1. The sine of 0, that's 0. And then multiplying it by the magnitude would give us the same vector. So what we want to do is we have this, we want to use the rope to close the door. So we want to see the rope projected onto that part that the door is going to slide over. So I want to go ahead and project the what did I call it? The door vector. I want to project that onto, or I'm sorry, I want to project the rope, I want to project the rope vector onto the door vector. So I want the rope in the direction of the door. So that means I need to have r dot d on top divided by, and then since I am projecting onto d, I need to have that magnitude of d squared. And then once we get that constant, we will multiply it through our vector d. So let's first find r dot d. So r dot d, we're going to need to take 25 times 12 plus 25 square root 3 times 0. So 25 times 12 is going to be 300. And that other part is just going to be 0. So my dot product is going to be 300. Now we need to find the magnitude of the door vector. So I need to find the magnitude of d. So that's going to be 12 squared plus 0 squared. Take the square root of that. Or you might have just been able to tell by looking at it, that magnitude is going to be 12. All right, so here we go. So I'm going to take that number that we just found and distribute it out. Oh, I'm sorry, not that number that we just found. I'm going to take the dot product, which is 300, over the magnitude, which is 12, squared. And then we are going to take that number and distribute it out over my door vector, which was 12, 0. So if I distribute that out, I'm actually going to end back up with 25, 0 for that guy. Now, if you remember from a minute ago, our formula is going to be the magnitude of the projection times the magnitude of that vector that you are trying to do whatever work on. So we're trying to pull this door across that vector that was at 12, 0. So I'm going to need the magnitude of that guy, and that was my door vector. So first of all, the magnitude of my projection, this right here, that 25, 0 is my projection. My magnitude is going to be 25. We can also go ahead and find that real quick. Here's my projection, so we'll find the magnitude of him. I'll have 25 squared plus 0 squared. Take the square root. He is 25. And then I have the magnitude of my door vector. Here's my door vector, that 12, 0. His magnitude is going to be 12, and I think we found that earlier, didn't we? Yeah, there he is. We don't have to do it again. So to get our final amount of work, we're going to take 25 times 12, and we are going to end up with 300. And apparently it's called 300 foot-pounds, which makes sense because one of those vectors, it's going to be in feet. The other one is going to be in pounds. How is work foot-pounds? I have no idea. It's been a long time since I've seen physics. So if you have a better idea of that, please let me know. All right, so I will be back on Monday. There's an assignment on Schoology for you. I will see you then.